As the title above suggests, in this video we are going to be working a rational function limit problem that involves careful consideration of both the left and right hand limits. So the problem we're going to be working is the limit as x tends to 2 of x cubed minus 8 divided by x minus 2, the quantity squared. So hopefully you recognize this as a perfect cube of the form a cubed minus b cubed, which is a minus b times a squared plus ab plus b squared. And you can expand this and you'll see that it equals this. But here the a term is x, the b term is the cube root of 8, which is 2. So a minus b will have the limit as x tends to 2. A minus b, here let me actually rewrite it here. Limit as x tends to 2. The a minus b term will be x minus 2, since the x is the a term and the 2 is the b term. A squared will be x squared, this is the a term, so this squared, plus a times b plus x times 2, so plus 2x. And then plus b squared, so plus 2 squared, which is 4. And in the denominator we'll be dividing by, we'll have x minus 2 squared, which is x minus 2 times x minus 2. This is a 4, hopefully you can see that. So one of these x minus 2's cancels with this x minus 2, and we do not have to worry about division by 0 because we're only concerned with values as x gets close to 2, not 2 itself. So this is the limit as x tends to 2 of x squared plus 2x plus 4 divided by x minus 2. So in the numerator we have, as x gets close to 2, x squared gets close to 2 squared, 2x gets close to 2 times 2, and 4 is just 4. The denominator we have 2 minus 2. So 2 squared is 4 plus 4 is 12 over 0. So you may be tempted to say this is positive infinity, right? 12 over 0 is positive infinity. And that's why I decided to work this problem, because what you have to be aware of is x can approach 2 from both the positive and the negative side. Or excuse me, I meant to say x can approach 2 from either above or below. So you can be coming in towards 2 from above, so say 2.1, 2.099, 2.098, and all the way down to 2.0001. Or you can become approaching 2 from below, so say 1.9, 1.91, 1.92, all the way up to 1.99999. So I've pulled up a graph of x squared plus 2x plus 4 over x minus 2 on the TI-83 graphing calculator. So we are going to zoom near here. We will zoom in. We are going to be looking near x equals 2. So we're at 1 1.91, and you can see this little cursor blinking at the bottom. I guess we're gonna have to zoom in a little bit further. Still further. Looks like that's the furthest we can zoom in here. Huh. Interesting. Okay, so I reset the window here so I could illustrate the point I'm trying to make. So here we have the graph of x squared plus 2x plus 4 over x minus 2. And that's what we're looking at, the limit as x tends to 2. And we would be tempted to say it's positive infinity, but if you look as x approaches from below, it looks like x is getting from 1.5 to 1.9. It drops, the function drops from negative 18.5 to negative 114.4. So if we wanted x equals 1.99999, we'd get an even more negative number. However, when we approach from the right, like say at 3.9, y is 14.2, 3.5, it's 15.5, but then you can see from 3.1 onwards, as we're getting closer and closer to 2, 3.1 it's 18, 2.7 it's 23.84, 2.3 it's 46, and it's going to take off. And the closer and closer you get to 2, the closer, as x tends to 2 from above, you'll see that this y goes to negative infinity. I know the graph unfortunately doesn't seem to illustrate this very well. Let me see if I can change the window one more time. Okay, so finally I've pulled up a graph of the function to the left of x equals 2, and you can see x is, and that's this function, x squared plus 2x plus 4 divided by x minus 2. Remember, with this calculation it seemed like the limit is positive infinity, but when we approach from the left, at x equals 1.94, y is already negative 231. At x equals 1.96, it's negative 298. At x equals 1.97, y is negative 419. When x reaches 1.98, y is almost negative 700. So you can pretty much see that as x approaches 2, y tends to negative. As x approaches 2 from below, y tends to negative infinity. At x is 1.9989, y is negative 11,274. Now we're going to be approaching x equals 2 from the right. So you can see when x is 2.02, y is 518. As x gets to 2.012, y is 986. As x gets to 2.007, y is 1,617. As x gets to 2.001, y is 11,286. So you can clearly see that as x approaches 2 from the right, this function, x squared plus 2x plus 4 over x minus 2, approaches positive infinity. So this is actually incorrect. The limit as x approaches 2 from the right of x squared plus 2x plus 4 divided by x minus 2 is positive infinity. And the limit as x approaches 2 from the left of x squared plus 2x plus 4 divided by x minus 2 is negative infinity. And these two limits are different coming in from the right, so we conclude that the limit does not exist, and we abbreviate that with DNE. But this 12 over 0, so what does that mean? Is 12 over 0 positive infinity or negative infinity? Well, remember that we're really not dividing by 0. We are dividing either by a small positive number when we're approaching 2, x equals 2 from the right, so 2.0001 minus 2 be a small positive number, in which case this limit would be positive infinity, and the value we'd be concerned with is a very big number, and we say that number we represent it as negative infinity or positive infinity. And approaching 2 from the left, we would be dividing by a very small negative number, so 1.99999 minus 2 be a very small negative number. 12 divided by a very, very small negative fraction would be negative infinity. Go ahead and close out this calculator here if I can. So here the limit doesn't exist because coming in from the left and the right, you don't converge on either positive infinity, or you converge on positive infinity in one case, I shouldn't say converge. Limit approaches positive infinity. Limit is positive infinity in one case and negative infinity in the other. When both limits, we're going to look at an example when both limits, left and right limits, approach infinity, and one in which both left and right limits approach negative infinity. Those limits have a definite interpretation. So the limit as x tends to 0 of 1 over x squared. Hopefully you remember that 1 over x squared, it'll contain 1, 1, and it will look something like this. You square a negative number, it's still positive. So as x tends to 0, both coming in from the right and the left, f of x tends to positive infinity. So we say this limit is positive infinity. Some teachers would write this as the limit does not exist, but some prefer you say it's positive infinity. And we'll look at one more. The limit as x tends to 0 of negative 1 over x squared. So limit as x tends to 0 of negative 1 over x squared. So the graph of negative 1 over x squared is for every point xy on the graph of f of x equals 1 over x squared, you know there's going to be a point x negative y on g of x equals negative 1 over x squared. So every point's basically, every x coordinate is going to be flipped over the x-axis. To get to get the negative of any function, to graph it, you are flipping the original function over the x-axis, because for every point x, y, there is a point negative, or x negative y. So here there's going to be the point, oh no, 2, 1/4. We'll say this is 2, 1/4. So 2, when x is 2, f of x is 1 over 2 squared, which is 1 over 4. On this function, you'll have the point 2, negative 1/4. So negative 1 over 2 squared, which is negative 1/4. And here you can see as x gets closer and closer to 0, both coming in from the left and the right, y tends to negative infinity, or g of x equals negative 1 over x squared tends to negative infinity. So you can see that here, even though some teachers would want you to write the limit doesn't exist in these two cases, there is a definite interpretation. While in this problem there wasn't, and because the limits from the left and the right, one approached positive infinity while the other approached negative infinity.